first and then review?
What?
Can we do the new stuff first and then just review?
You prefer that?
That's a logical.
Yeah, of course. That sounds
And now you guys can review and then tell me
We're reviewing it. We're gonna do stuff.
It'll be on. It'll be on.
The new stuff will be on the test too.
No. So the test, like I said, Thursday, October 2nd, 1.1 through 1.6. Of course, limits, something you have to know. I'm just going to ask you to do a bunch of limits. Know about continuity. Be able to say where a function is continuous. Be able to find arbitrary, I don't know how to say that, values to make a function continuous. What I mean by that is those guys where you get f of x equals blah 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 blah, and there's an a and a b somewhere, and you have to find a and b to make it continuous. Intermediate value theorem. Make sure you know how to state it and everything. What else? Difference quotient. Know how to set that up and simplify it. That's the guy that from the derivative, so f of x plus h minus f of x over h, or f of x minus f of a over x minus a, things of that sort. Composite functions in general. Limits, continuity, intermediate value theorem, composite function. Yeah, pretty much. Overall, that's what we'll be doing on the test. Questions on anything? Any of the?
I did have a question on what's the structure for it on multiple choice response?
No, like show all your work to do a problem. So it won't be like quizzes. Like you'll get partial credit. You have to show all your steps. Now scrutinize all the steps.
Okay. How many questions?
4 or 5.
What?
Oh,
Each one's like 20 feet.
4 or 5. Well, I mean, the question on limits will probably have several parts.
So each one is like 20 points.
Yeah.
Multiple choice.
No multiple choice. Any other questions?
Do you have questions or?
Well, I posted a bunch of questions on the review. I'd go over them if you guys want to. But I thought you guys wanted to do new stuff first. Okay. Where did we stop off last time? We're in 2.1/2.2. And I believe we found the tangent line to y equals x squared at a certain point or something like that?
Yeah.
Y equals x squared at the point x equals 2 or something.
Yeah.
Right, so recall for a function y equals f of x. The derivative is defined as, you can call it f prime of x, or you might call it dy dx. We're going to talk about these different notations soon. It's defined as a limit as h approaches 0 of f of x plus h minus f of x over h, which is actually equivalent to something like the limit as x approaches a of f of x minus f of a over x minus a. So basically you start with a difference quotient and you take a limit, and that ends up with the derivative. Right, so, and we actually did an example. We found that there's some more notation for you. I've showed you this notation before. This just means that the derivative of x, right? X squared, and we found that that was 2x when we did all this mumbo jumbo, right? And basically was a formula that gave you the slope at any point. So if you want to know what is the slope of the tangent line at a certain point, you just plug it into the function 2x. So 2y equals x squared add x. So basically that's what 2.1 and 2.2 were talking about. It was introducing the derivative, which is a measure of slope, which can be interpreted as rate of change, how fast something is changing. We sort of covered last time. There's not really much more to talk about. I'm just going to do a few more examples. Probably how a question would be phrased on, say, test 2 could be something like this. Use the definition of the derivative. Going to talk about some functions that are commonly show up, something like 1 over x plus 1 over x equals radicals, or x equals x plus 1 over x plus 2. Right, so this is a typical question that you'll see asked. You'll no doubt see it asked on the final. Shows up pretty much on every final. Right? See here. Use the definition to find f prime. Right? They always give you a question like that. Right? And when they say definition, they're talking about the limit definition. So how would we go about finding something like this? Where do we start?
Start from the
one way you can do it. For that function, what is f of x plus h?
1 over x plus h.
1 over x plus h plus 1 minus 1 over x plus 1 all over h. How do we simplify that?
Just find the common denominators.
Okay. What's the, well, you can't put in 0 for h, it's in the denominator. You
X
can't do
plus
that.
1 minus x plus h plus 1 over x.
Right, you multiply top and bottom by the LCD. It's one of the best ways you learn in algebra to simplify complex fractions. So this guy, of course, distributes. You take it, multiply this, you take it and multiply that. In the first case, what do you get? These guys would cancel, you just get x plus 1 minus, in this case, this would cancel, you get x plus h plus 1. Bottom left. Yes, you have to keep writing this limit until you actually take the limit, plug in h equals 0. And yes, I will deduct points if you don't. Alright, so now where are we? Well, the x would kill the x, the 1 would kill the 1, and then I just have minus h on top, which will cancel with the h on the bottom. So this just becomes minus 1. And now if I plug in h equals 0, the denominator is not 0 as long as x is not minus 1. And I end up with minus 1 over x plus 1 squared.
So when do you know if you have to use f of x plus h minus f of x or the other one, which was like f of x minus f of x?
Typically it would be up to you.
So either way.
Yeah.
We want to get rid of the
Come again?
get rid of the H.
Because the h in the top here cancel the 1 here. Right? Because the x and the 1 disappeared and it only had an h on top.
Professor, you see how there you wrote x plus h plus 1. You can position that h at the end also, right?
You mean this h?
Yeah.
You mean x plus 1 plus h?
Yeah, x plus h plus 1. Yeah, I can position that as x plus 1 plus h, right?
You mean x plus 1 plus h?
Yeah.
Like that? Yeah, that would make a difference.
Right.
What would be bad is if you did this. That's totally wrong. But yeah, typically you can use the f of x minus f of a over x minus a. Usually it will be up to you which version of the difference quotient you use. But this one shows up, so I always use that one. As far as b is concerned, our f prime of x would be equal to, what is f of x plus h for part b? Huh? Radical x plus h minus radical x all over h, limit. How do we simplify this one? Conjugate. Right? So this is where your algebra comes into play, right? Being able to simplify these things and know what to do when you see strange things like this. Right? So then the top becomes x plus h minus x over x of course is that one, and the h is cancelled. And finally, now I can plug in h equals 0 because the denominator will not be 0 anymore. So this is just 1 over 2 radical x in the bottom. Yes.
So if I wanted to write that's just not to write radical x plus radical x, then do I have to put the limit, or does that not count?
If you, from here, you're at 1 over radical x plus radical x.
Yeah.
No, you wouldn't write the limit because you actually plugged in h equals 0.
Okay.
Once you actually plug in h equals 0, that's when you can draw this. So before that, you don't draw it. So this is sort of like part A, but it just is slightly more complicated. In this case, f prime of x equals, what does f of x plus h for that function look like?
X plus h plus b.
X plus h plus 1 over
X plus h plus b.
x plus h plus 2 minus x plus 1 over x plus 2 all over h, and then we have the limit. You simplify this pretty similarly how you did that one. The LCD here is x plus 2 times x plus h plus 2, multiply top and bottom by that. In the first case, these would cancel, it would be left over that numerator. You'd be left with x plus h plus 1 times x plus 2.
Wait, I don't get how you got x plus h plus 1 from that.
Our function was f of x equals x plus 1 over x plus 2, right? F of x plus h just means each x you replace with x plus h.
Oh.
So I get x plus h plus 1, x plus h plus 2. Right? Each instance of x you replace with x plus h. Minus, this one would be x plus 1 times x plus h plus 2. Now what? Multiply out, expand the brackets, right? That's what else can you use, right? So you start here, what would this be? Minus, open brackets, very important. Then we do the same thing, x squared plus xh plus 2x plus x plus h plus 2. By the way, these are very nice examples. I'm finding they're really going to test your algebra skills in this sort of thing. So x squares would die, 2x's would die, xh would die, this, that, this, that. And so what do I have? I would have 2h minus h, right? And then that h would cancel, so that would be just 1 over this. And so that would be what? Now I can just plug in h equals 0, because the denominator is not 0. Yep. Yes.
So you said, this won't be a simple form of 5, you said?
No, I mean that x plus 1 over x plus 2 is a pretty nice function. No?
Yeah.
No.
Radicate stuff like that?
No, they could put something like f of x equals radical x over x plus 1 squared or something stupid stuff. They can make it complicated, trust me. Right? Look at this little stupid function. It gives you all of this. You know, just be prepared for the worst. Let's put it that way. Follow-up question. So in part B, I let f of x equals radical x, I think. So now, and again, this is very typical. After they ask you to do something using limit definition, they're going to ask you to find a tangent line. It's a very, very typical kind of problem.
Do you have access to a full file?
Yeah, there are like 5 for them on I gave you the link for them. It's on my website.
Is that the same thing you have previous first test online also?
What?
Yeah, previous first test online also? Like previous
No,
years?
no, just fine. Only fine. How do we do this one?
So since when you finish 2.1 and 2.2 today, right?
Yeah.
Then is it not going to be good on Thursday? Because
No, Thursday we have an exam.
so
Or we'll be
Tuesday.
Tuesday. So, yeah, because you need to study it.
yeah, exactly.
Okay, so.
Because all those awareness.
No, it's extended. I extended it. It's not due yet. Chapter 2 homeworks?
Yeah.
That's due next week. For web assignment. Okay, so how do we do this one? Yes? Right, first you have to find the corresponding y value. Since x equals 4, y is equal to radical 4 equals 2, this means that the point we're considering is 4, 2, okay? Which we're going to use as our x1, y1 in the equation of a line, okay? What else? That's the first thing you needed. The second thing you needed. The slope. How do we get the slope? The derivative gives you the slope, right? Now we need the slope. Now the slope is just going to be our derivative, which we had was this, and you're going to just evaluate it when x equals 4. So you're going to pretty much plug in x equals 4. That gives you a quarter. Therefore, the tangent line is y minus 2 equals x minus 4. Right? Because y minus y1 equals n x minus x. And that's it. So basically this means on the function y equals x radical x, if you take a point x equals 4 and y equals 2 and you drew a tangent line there, the equation of that line is going to be y minus 2 equals a quarter x minus 4. Which tells you the rate of change. Well, the slope is the rate of change.
Give me like that. You want to simplify it.
What, this?
No, yeah.
Yeah. Like that. In fact, a lot of times I write up solutions, I leave it like that, and if you put it in y equals m, it's supposed to be 4, and it's like, it's like right there, so step down. I hate it when that happens sometimes. Like I solve it one way, and then someone else does another. To do it the other way. Okay. Here's something neat. Well, sure, let's do it. Suppose f of x equals x to the n, and is a positive integer. Find f prime. So here we use limit. So h goes to 0, up now we have x plus h to the n minus x to the n over h. Right? You guys remember how to expand something like that?
Binomial theorem.
Binomial theorem. So this would look like x to the n plus n choose 1, x to the n minus 1 h plus n choose 2, x to the n minus 2 h squared. If you don't know this notation, don't worry about it, but hopefully you guys could write it out in numbers. Minus x to the n all over h. Turns out that these guys would cancel, and it turns out that your h would cancel with this guy, and then kill one power of everyone else. So basically now when you plug in h equals 0, you end up with which n choose 1 is actually just n. That's just weird notation for the Pascal coefficients. And you actually get that formula. So you can use this formula. If f of x looks like x to the n, then f prime of x will actually always look like x to the n minus 1. So example, we did this before. The derivative of x squared was what? N is 2. So you take that, you put it down in front, subtract 1 from that to x. Right? What about x cubed? 3x squared. I mean, if you went through and you did all of this for x cubed, expanding the cube, you know, x cubed plus 3x squared plus times h and all that. When you dust settles and you plug in h equals 0, that's what you'd end up with, right? Yes?
What if it's like 2x squared? Or 2x cubed?
Oh, well, that's a... Yes, you can factor out constants. I want to show you something else before that, though. This actually works in general. So, for example, we know what the derivative of radical x is. Does it actually work here? Well, this is just that you write it as a power, x to the half, so now your n is a half, and if I do that, what do I get? A half x to the minus 1 half, because it's a half minus 1. Or what is that? That's actually 1 over 2 radical x. Right? Back to that.
X negative 1. X negative 1. The derivative of x.
It's the derivative of x to the minus 1, which is minus x to the minus 2, minus 1 over x squared. And that's also one we've done before. You'll notice that if you look back in your notes. When we did the whole quotient thing, that's what we ended up. So it turns out that, yeah, the derivative starts as a limit. But when we move on, we're going to have nice formulas for this limit. We're not going to have to compute it all the time. We're just going to compute things in general. Here's a question. Someone says it's cosine. How do you know it's cosine? Prove it. If you want to find the derivative of this guy, what would you do? You take the limit, as h approaches 0, of sine of x plus h minus sine of x all over h, right? How would you simplify that? What is sine of x plus h? Addition formula for sine.
Sine of x cosine y plus
Sine x cosine h plus sine of h cosine x. Now what? The trick now is to actually rearrange things slightly. I'd rearrange it like that, just put this sign beside this one. And yes, now what I'm going to do is I'm going to separate this, right? Treat this as two separate fractions. Sine x is a common term, I can factor that out. This ends up being sine x times cosine h minus 1 over h plus sine h over h times cosine. What's cosine x minus 1 over x as x goes to 0? That's 0. That's a special trig limit. What's the limit as h goes to 0 of sine h over h? That's actually 1. So at the end of the day, this ends up being cosine. So, similarly, you can actually prove that the derivative of cosine will actually give you minus sine. You can actually go through this and use your special trig limits and you can derive that as well. So we're going to come back and generalize these formulas even more pretty soon, but I just thought I'd show you guys that. We're actually jumping a little bit into 2.3. Maybe I'll just do 2.1 slash 2.2 2.3. It all just flows into it. Do you guys want to keep going or do you want to exercise?
No. What time do you know?
It's 5:40.
Reviews.
We have 35 minutes left.
Oh, reviews.
What?
That's as important as the lessons.
Okay. Yeah. Okay. We'll stop there. We'll do more stuff. Like next time we'll talk about, the derivative is a limit, and we know that limits can not exist. So we have to talk about, what happens when the derivative limit doesn't exist. It turns out that you can have a function not have a derivative, or not have one at a certain point. And I guess we'll talk about when that happens next time, and that will finish off 2.1 and 2.2. But for now, we can move ahead. But now we have these three nice formulas. So if you actually do things the long way, you can actually come back and check them with the short way. Right? Which is how you're going to do it in the final, right? When you do this whole thing in the final, you just go to the side and do the short way. Like, okay, I'm right. Okay. Because they'll specifically ask you for the long way. It's something they're going to ask you to do.
On the what?
On the final.
Half the long one. Finish off. Sure.
No.
So if we answer the short way, you just get it wrong?
Yep.
No partial credit?
Nope. Okay, questions? Yes?
The last quiz had a question about the IVT, and you were supposed to explain. Oh, you answered that, right?
Yeah.
Or no?
And any questions from the past finals, like you guys looked at these guys? Any questions?
Can I use some composite function?
Well, composite functions just be like, I could actually use the difference quotients, or I could say something like, I could ask you things like that. Where is it? So I can give you two functions and it see the plugs in one into the other.
Wait, when it's like f of g of, then it's 5, that's assuming that's x, right? Like 5 of x.
Yes. Of x or f of g of x. That's really how you want to think about it. The g is being plugged into the x. And so what would that be here? So f of g of x just means, let me. Means everywhere you see an x, you're just going to put a g of x instead. I mean, you could start out by writing it this way if you think you get confused. Just go in and replace all the x's with g of x first. Now you just jump down to this one. So g of x is 2x plus 4 squared. 2 times 2x plus 4 plus 1. And then now you can simplify this. 16x. What's 3 times 16? 3 times 16.
48.
X plus 4, so that's 52x plus 48 plus 9 is 57. So somewhere. You guys want me to do this one?
This one.
Yeah, things like that. Plugging one thing into the other. You should be able to do that. Other questions?
C. Part C.
You want to do part C? Okay. Let's do part C and then we'll do some limit problems. Okay, what would that look like here? What would I get? Well, it's just 3x squared plus 2x plus 1 plus h minus. Right? I was just waiting for someone to say yes. No, everywhere you see x, you put x plus h. You know on the quiz I catch the people who actually put the plus h at the end? You'll always get 1 when you do that, like all the time. So if I see you put a 1, yeah, that's what they do. Plug it in. Right, minus f of x all over h. And I sort of have to expand this guy. this is going to die with that. This dies with that. This dies with that. What I'm going to have, I'm going to have 6xh plus 3h squared plus 2h all over h. And then the h just cancels. I didn't cancel across sums, I actually factored out. So this is 6x plus 3h plus 2. Here's something for fun. Plug in h equals 0, what do you get?
6x plus 2.
6x plus 2.
You get 6x plus 2. Now check this out. Oh, I didn't show you guys how to take constants, right?
Constants go to 0.
Right, the trick is you can sort of think of a constant like something like x to the 0 power. Right? So the 0 comes down and kill. Right? So if I were to take the derivative here, according to the short rule, the constants stay outside. We're going to go over these rules soon. For this, you take the 2 down. Here, this is x to the 1. Take the 1 down, you get 2. Minus 1, you get 0. So that's just 2. So you just get 6x plus 2, which is over here. Right?
Did you allow this on the test? You want us to do that?
If you ask for this, you have to do this, right? So if they say use limits or use the definition of the derivative, you have to do this.
So when they found out about the derivative, why wouldn't they just get rid of the limits?
Huh?
So when they found out about the derivative.
Well, it's important to know this because there are functions where we don't have a nice formula for them. And so sometimes you just have to go back to basics. Yeah, it's a pain, but you know, we come with nice formulas whenever we can.
Painful or odd or even problems.
Yeah.
That's why it is reading.
Even f of x is even if, what's the condition? F of minus x equals f of x, right? Meaning if you replace all the x's with minus x, it makes no difference, right? It's odd if f of x is odd if. When you replace all the x's with minus x, you have to get the negative of the function. And so at this point, the only sort of question I can really ask you, which function is odd or even? We did something like this before. Who's odd, who's even? Or neither? A?
Yeah.
A is odd. Do we see why it's odd? Because if I take f of minus x, it's just minus x times minus x in absolute values, which is just minus x. Absolute values kill the negative. So you get the negative of the original function. replace it with minus x, you get a negative in front of the whole thing, which is what happens
So you
here.
replace for both of them, right?
All instances of derivatives. It's a composite function.
State.
Ever raise the x, you put a minus x instead and see what happens, right? If it made no difference, it's even. If it actually makes, you get the negative of the original, it's odd. If anything else happens, it's neither. What about f of x? This one. This is neither. How do you know? Because if you take f of minus x, you get minus x cubed plus x squared plus 1. And that is not the original. And it's also not the negative of the original either. It's something else. So it's neither. What about this one? This is even. Take f of minus x, you get minus x to the 4th plus 2 times minus x squared. But you're raising things to an even power. That's just the original function. So it's even. Neither. So if you take f of minus x, you would get minus x over minus x to the 4th plus 1. That would actually minus x over x to the 4th plus 1. That's actually just a negative of the original, so this is actually odd. Here, if I take x.
Professor,
Yes.
how that be, doesn't the one has to be negative as well?
No?
Just the x?
Yes. I mean, minus a over b is equal to minus a all over b, or a over minus b. You can only apply the negative in one position. You put minus x squared over 1 minus x cubed. This would give you minus x squared. This would give you x squared over 1 plus x cubed. So it's neither.
So can you please go over some limits involved and long absence?
Wait, someone asked me about the next group. Yes.
I want to understand this even on from a given graph.
Even, it means it's mirrored over the y-axis. So for example, y equals x squared is even because if you take the right side here and mirror it over there, you get that. Or cosine is also even. Because if you take one side, you mirror it over the y-axis, you get the other side. Odd, it's reflected about the origin. So something like x cubed is odd, or sine x is odd. Because if you take the right side, flip it in the y-axis, then flip the result in the x-axis, you get the other side. That means it's odd. So it's just about symmetry. That's really what it means. Okay, what's the answer? What? What is it? It's 1.
Why?
The 7.
Did all the stuff for even and odd and like
if you expanded the bottom, you would get 7u to the 4th plus some change, right? Remember when you go to infinity, you only look at the biggest powers. If the powers are the same, you take the ratio of the coefficients.
But do we have to show all the vertices?
For something like this, no.
Show some cases.
Right now, it's all
I'm going to try. What's that?
1/5.
What you do here is you factor out that x squared, go to 25 plus 1 over x squared.
Why do you talk about 25? Because it's not. You just said you just took out the x squared?
Yes, the x
So
squared.
why do you take out 25 x squared?
I could have, but I didn't want to, because then I get something that looks like this. What's worse? It's not necessary. Because this guy is going to go to 0 anyway, so there's no real reason to rush with the 25. This guy is actually by x. But we're going to infinity, so this is just plus x, right? And so now what I can do is I can divide top and bottom by x. This would go to 0, this would go to 0, and the result would be 1 over 5. Questions?
So can you please do the same thing using very infinity as well? Thank you.
Right, so if they had said x goes to negative infinity, things would have been different.
Professor, for that, the last problem, right? Can you just look at the 25x squared and just make it 5x and just cross it out?
Yeah, I mean, at any given point, if you're going to infinity, then the lower guys really don't matter. So you could essentially ignore them. One thing you have to worry about, though, is the powers. Because then you don't just always just get x, sometimes you get absolute values. The powers are odd, you don't really have to worry about it. Why did I what? Where did I divide? I didn't divide.
took out the x squared.
I just factored out the x squared that was here. I pulled it out. Because I wanted to come outside so I could cancel. So it's just a factor.
1 over x squared is 0, right? So 25 plus 0 is 25. The square root of 25 is 5.
Yes, as x goes to infinity, 1 over x squared goes to 0.
Why didn't you do that earlier? X equals 2.
I just, I keep taking the limit, I just do it all at once.
Professor, I was confused on that. You have x plus 2 and on the next step you got 1 plus 2 over x. I mean, that's it.
I divided top and bottom by x.
Why would you do that?
You can do the same stuff.
Because the highest power in the
Oh, okay.
Wait, Mr. When it's infinity, you know how it's positive? Don't you have, I mean, like that infinity, don't you have to look at both of them? At both of them. You just look at the positive.
Yeah.
Shouldn't have.
The only time where you look at two sides of a limit with an absolute value is if you pass a point where it's 0, which is not happening. So if you were doing this guy, it would look pretty much the same up to this point. Except now this guy would be replaced by minus x. And so you get minus 1. What's that? Three. Yeah.
In some cases, they ask me to find the limit of fraction, and it says like 2 plus or 3 plus. How do you approach that? I mean,
This tells you the direction. So it says you're approaching 2 from the right side.
So if there was no absolute value, how would you approach that? If it says that 2 plus, what do you plug in? Just for a simple fraction, no absolute, just like no fraction. It says like 2 plus. I know if you would have to 2 plus.
So just the same thing but no absolute value?
Yeah, that's what
X. Right, so 2 plus just means you're a little bigger than 2. Right, so on the number line where 2 is, you're approaching from this side. So now what happens is you'd realize your first instinct would be, oh, try to factor and cancel that thing, right? So you'd go, okay, if I do this guy, oh, 3 is a common term. So you do that, and then you realize it doesn't help, I still can't cancel. So now you're like, it's going to be infinite, right? Because you're approaching 0, and there's nothing to stop you from almost dividing by 0. So what's going to happen is you sort of watch the signs of each part, right? So this would approach, if your x is a little bigger than 2, right? X minus 2 is always going to be a little positive, right? So it's going to be like 2.001 minus 2, you get that, right? So this guy, the denominator, you sort of think of it as 0 plus, right? You're approaching 0, a little bit more than 0, right? Whereas this guy, as x is approaching 2, this is approaching what? Right, 2 plus 3, which is 5 times 3, so that's 15. Since both of these are positive numbers, it goes to positive infinity.
Oh, you just like,
You watch the signs. You know it's going to be infinity, you just need to know, is it positive or negative?
But I'd say that when I ask you again infinity of negative infinity, when the bottom is 0, like if you plug it in, and nothing can go out of infinity.
Yes. For example, if it was 2 from the left, it would have been negative infinity. The bottom would have been negative. What about this one?
we got it. It's always do like this, right?
It actually gives you that. bigger than 2, what's inside the absolute value is positive, and the absolute value just won't do anything. It'll just be like easy to solve. And so this would actually give you plus infinity. And the flip side of this is I can say 2 from the left of 3x plus 9 over x minus 2. And what the absolute value is going to do, since you're a little less than 2, inside is negative. So the absolute value is going to give you the negative of this side. 3x plus 9, and this would be minus x minus 2. In which case that would go to negative infinity. Yes?
So let's say you have 1 over x and you have limit x approaching from the left. Would that be negative 1?
But it's 2 from the left?
Let's say you have 1 over x. Like limit x approaches 2 from the left of 1 over x.
Wait, hold on.
But not that.
Would this be positive or negative here? You're approaching 2 from the left, so what's happening with the x? It's like
It's going to be negative.
1.99, right? Minus 2, that's going to be negative, but then I'm taking a negative again.
Positive, so it's positive.
It's actually positive. Trick question. Okay. What was your question now?
So if you have like limit as x approaches 2 from the left of 1 over x, would that be negative 1?
Limit as x approaches 2 from the left of x minus 2?
No, just x.
Oh, well, that'll just be a half.
Would it be negative?
You can just plug it in because you're not undefined here.
For example, if you have a calculate x plus 2, and let's say it as x versus 2 plus.
Limit as x approaches 2 from the right of just x plus 2. It's just 4.
When you went equal to 0 at the bottom, then you look for limit infinity of
Yeah, if you're continuous at the number, just plug in the number. It doesn't matter what side you're approaching from. Yeah.
Can you give us an example where the limit exists? If you know it by heart.
Well, there are tons. Like, that doesn't exist. How do we know it doesn't exist?
You cannot.
It turns out if you're approaching 2 from the right side, means your x is a little bigger than 2. This would go to 0 plus, which is positive infinity. However, if you're approaching 2 from the left side, this would go to 0 minus, which is equal to negative. So limit does not exist. How do you do something like that?
It means positive infinity in both cases just because of the absolute value, right? That's the last question.
Yes, that's why this worked out.
So it's only infinity or negative infinity when the bottom doesn't have like a square across it?
Right, if the bottom is going to 0, it will blow up.
Okay.
The only way you can stop it is if the numerator cancels it. But if that doesn't happen, it's going to infinity. All you have to do now is watch the signs. Yeah. Other questions?
So plug in 0 and it does equal 0. Like if you cancel that, then it equals 0.
If you have this approaching something like and you cannot cancel the 0 factor. the top is equal to 0. A fraction can only be 0 if the top is 0. So for a fraction to be 0, the top has to be equal to 0. And the bottom not being 0 at the same time. That sort of thing. Cases where you have 0 or 0, you'll deal with that more in top 2. Questions?
So professor.
Huh? How would you do this one? Why would you take it from both sides? The trick would be to see that you can actually factor this guy. It's x minus 3 times x plus 2. Now, you can factor the top, hoping that something cancels.
Uh-oh.
And you're like, yes, we can kill this guy, but it actually won't save you because this one is the problem.
Yeah.
So now what?
We're screwed.
Like, yeah! No. Which, by the way, in general,
Does not exist?
even if that was the problem, you should remember that x minus a over x minus a and these do not exist, right? Because if you're approaching from different directions, one will give you a negative, one will give you a positive. So it'll cancel, one will give you a plus one, one will give you a negative one. The graph will always look like this. Alright, so those will not exist. So even if you cancel this guy and you're approaching minus 2, you still wouldn't exist. But in this case, what would happen? So there's nothing to cancel that x minus 3, which is the bad guy, so you're going to be infinite. Now it's just worrying about the signs, right? So if you're approaching 3 from the left side, what's going to happen? The top is always going to be positive if you're going to 3. What about the bottom? It's also always going to be positive because you're in absolute values, right? So this would actually be plus infinity.
If it was when approaching x, wait, when approaching 3 from the left, would that make the x negative?
Yes, but what would happen is here? So this would be negative, but it's negative anyways. Correct.
Is that direction?
Huh?
Is that the value that gives it a direction?
Yeah. The absolute value keeps it positive, right? So since the numerator is
So in
positive,
any case, if it's an absolute value and it's an what would be considered to define as one absolute value, it would be a positive effect. Or there
if the numerator was positive, if this was minus, then that would be negative. So pretty much you watch the signs of everyone except the absolute value. I guess you can stop.